Hello and welcome to AP Human Geography. Today what we want to talk about is a little overview about maps and how we make them. So first I'm going to start with your mini quiz question, and one of the things that we're going to talk about is place, right? What does place mean? So when we talk about human geography, when we talk about a place, what are we talking about? A point where a natural resource is located, a location of the Earth's surface with a distinctive characteristic, a subunit of a region composed of villages or small towns, a point formed by the intersection of two or more transportation lines, a location where people live and work. Well, it turns out that when you're talking about some place, you're just talking about a location of the Earth's surface with a distinctive characteristic, right? So this one. And it can be anything. Actually, all of these things are places, right? It's just a broad definition, which brings us to two more definitions that you really need to know, and that is site and situation. And those are very important and they are very different. The site is the physical nature of where something is located, right? So let's say that you want to have a settlement. You need to have a water supply and it needs to be there with you on site, right, at the site. And then there's the site of the water supply, and it should be close to the site of your settlement. Your food supply should be close, right, all of those things. The situation is how close those things are, right? And so your settlement is going to have other settlements, right, that it may have connections with. And so the situation is kind of what's available around you in terms of relationships, right? Predominantly, it's going to be to some other site. Now, there is a little catch here. In your site, you can have a water supply that's for your site, but if that water supply starts getting too far away, then it becomes part of a situation, especially if you're sharing it, say, with another settlement, right? And so there's some fluidity a little bit to these definitions, but basically site is where it is, situation is where it is in the relative world, where everything else is. Yeah? Okay, so let's talk about maps, because ultimately if you're talking about places, the best way to see them is on a map. So maps, we obviously use them to determine where you're going. You're going to use these all the time, and hopefully by the time you're done with this class, you can read a map and don't have to rely solely on the voice on your phone to get places. You can model the Earth's surface. You can see what's going on, locate various places, sites and situations, and you can just show the distribution of features or materials. And all of these have many different reasons for why they're important, and we will do all of those things throughout the class. Now, there's a couple other things that you need to keep in mind about maps, right? First of all, it's just a generalized view of an area as seen from above, and it's reduced in size, okay? So what that means is that you are projecting this spherical three-dimensional thing, right? Spheres are three-dimensional, to a two-dimensional surface, a flat map. And there are different ways to do that, and we'll talk about how to project turning this 3D into 2D kind of a thing. And then the other thing that you have to keep in mind is the scale of the map. And this is the ratio of the map units to the ground units. And scales are really important because we're really trying to get that perspective of where everything is situated. Okay, so those are some definitions for you. I briefly want to talk a little bit about the different kinds of maps. And we did this on the first day of class, and we kind of looked and said, oh, what do these maps tell us? But I want to give you the official categories of maps right now. And the first one is probably the one you're most familiar with. These are the political maps. They are about boundaries, right? Countries, states, cities, whatever. Usually you have symbols that will differentiate capitals from other cities. Sometimes it's only capitals. Sometimes they don't have any cities on them at all. But basically, this is going to be just borders, right? And they're usually in different colors to make it easy to compare the size, the shape, and the location of whatever you're talking about. This is a very typical political map. Right? Some of these boundaries, as we've discussed, correspond to actual physical geographic characteristics. Some are arbitrary. All right, and I mean arbitrary in relation to geography. They're not I mean, some boundaries are just arbitrary, but most boundaries have a reason for where they are, why they are where they are. But in terms of like geography, they may seem arbitrary. Okay. Now, the next kind of map is a physical map. This is something that will show you natural features, right? Most of the time, there are going to be colors that correspond with those features, so you can see patterns. Really good examples are vegetation, elevation, rivers, whatever. A lot of times they'll have names of natural features, but that's not a guarantee. And that just depends on the map. Now, some physical maps also include political information such as boundaries, but when you're dealing with a physical map, you're really focusing on those natural characteristics. All right, so here is a good example of a physical map. We saw some of these on the first day of class as well. Now, the third kind of map we want to talk about are topographic maps, and some of you will have seen these before and some of you won't. Topographic maps show you a flattened kind of almost like cartoon looking version. They're drawn, but what they're going to show you is contour, right? The contour of the area. They're going to give you political boundaries. They're going to give you major features. These are specifically for locating and kind of things, right, in relation to other things. These are situational. The military, for instance, uses topographic maps for navigation and stuff like that over terrain. And what they're really showing you is the lay of the land. They are sort of this combination of physical and political maps, but in terms of physical, they don't really use a lot of color gradients to show you different stuff. It's really done with contour lines, and it's specifically about elevation, right? It's showing you the relief. You can calculate all of this stuff, by the way, and we're not going to go into a lot of detail about calculating the elevation in between various contour lines, but it is a really cool thing, and if you are a hiker, you probably have done that before, right? But just so you know, the closer the lines are together, the steeper something is. So what you're looking at here is this nice little tabletop, right, little plateau thing, and you can see that you have very steep sides, and then you have a very flat surface that you can see is about 5,100 feet, right? This mark right here is actually at 5,117 feet, right? But here's the 5,000 mark, here's the 4,700, here's the 4,500. So you can see that this goes up 300 feet in the same distance that this goes 200 feet, right? So this is a lot steeper. But anyway, that's the point on the topographic map. We'll use some of these. They're all measured from sea level. But we won't use a lot of these necessarily. Now, the other big map that we're going to be using are thematic maps. You've seen lots of these. These are like physical maps. In many ways, they can show some of the same things. But this is where you start looking at resource distribution, population densities, right? Economic activities. They're going to show historical trends. They may show movements of people. They may show distributions of ideas, right? Here's a climate map, and you can see that this is different than a physical map, right? And so we've got these false color images of these climate types, but they're not actually related specifically to something on the ground. And that's the difference between a physical and a thematic map. They are not related to something specific on the ground, okay? Directly. They are, obviously. The vegetation map that we looked at also showed us climate, right? Because different kinds of vegetation exist in different climates. But the vegetation itself was the direct physical feature. The climate is the theme that you're seeing, okay? And so in this case, we've just done it by climate. I hope that makes sense. If you have any questions about that, please ask me. Okay, here's the mineral distribution around the world of some of the key valuable minerals that we mine. You can see the other thing that's really important, and I want to mention, is the legend. Okay, anytime you have colors or shapes or markers on your map, you need to have a legend that tells you what that is. Otherwise, the map is pretty useless because you don't know what you're talking about. Here again, you can see the legend, right? This is another vegetation map, although in this case it's done in regions. So this again is a combo of a thematic physical map. Here's wind resources, right? This is not something that you could actually see on a physical map because you can't directly map the wind. You can map the amount of winds a place gets, you can map the direction in which the wind is going at any given time, but this is going to be an overview of how much wind these areas are getting, and once again, Legend. Yeah, and we're going to come back to this wind map later on in the class. Here's a migration map. You can see that we're talking about the Bantu tribe and how they're actually really important to our conversation about language that will come up later on, and oddly enough, dairying. Anyway, so we're going to see how they've migrated across Africa, and you can see this is a historical trend. All right, now projection. We are going to have distortion in any map that you are looking at. The majority of maps we're going to look at are these Mercator projections that we've talked about before. Remember, the problem with Mercator projections is they blow out the poles. Okay, Antarctica and Greenland are not that big. And you can see from this map where you actually just got the northern hemisphere, but we're keeping true the sizes. Greenland is actually very tiny. It's not the same size as South America. It's small comparatively. So the conic projection and the Mercator projection are going to be the two we use most. Mercator has a lot of distortion. The conic projection really helps fix some of that. Okay, now place we know is the unique location of a feature. Location we know deals with site and situation, but then there are two other things we want to go with there, and that is the name and the mathematical location. Okay, when we talk about the name of a place, we are talking about its toponym, right? And we'll talk about toponyms a lot because toponyms can tell you a lot about the culture that lives there. So that's going to come up in a different unit of conversation. So I just want to mention it now when we're discussing location, because these are the four things that go with every location. Then there's the mathematical location, and that's going to refer to latitude and longitude. So here's your next question. The prime meridian is a meridian that cannot be divided by a whole number. Math people should laugh at that. 0 longitude, 360 degrees longitude, 180 degrees longitude, or located in Greenwich, Connecticut. Sometimes we'll talk about time, and we'll say Greenwich Mean Time. It's actually Greenwich, England, not Connecticut, so that is definitely not the answer. The prime meridian is 0 degrees longitude. So really we want to figure out what that means, okay? Location of any place can be described very accurately, very precisely by meridians and parallels. Okay, so meridians are lines of longitude. These are the great circles that will divide the Earth, okay, and 0 is the prime meridian. Okay, and then we have our parallels, which are the lines of latitude. Only one of those is a great circle, and that's the equator. Great circles will divide the Earth directly in half. Small circles don't. Right? And so in lines of latitude, there's only one latitude line, 0, the equator, that will divide the Earth directly in half. Everything else is a parallel slice off that. Longitude lines are not parallel to each other because they all converge at the poles. They are, however, all great circles. Okay, just as an aside. Right? And here's just a little bit how longitude works. Right? So we've got 0, and then we go west from 0, and we go east from 0. Okay, oh, and then here is the prime meridian, and which is right here, okay? And this is where we talk a little bit about time zones. So as the Earth rotates, the sun is going to be in a different place for different people, right? And so let's say that it's 7 p.m. in Greenwich Mean Time, right? And so that's here in England. And so it's 7 p.m. here. Well, that's what the sun looks like to them, because if the sun is, say, over here, right, that's the sun angle, yeah? But if you are in Dallas, which is right about here, okay, you're actually in Central Time Zone, right? And it's 1 p.m. because the sun is a lot closer to us in that respect than it is for the people who are on the prime meridian. And so that's how time zones work. As the Earth rotates under the sun over here, the sun is going to be in a different position. And the time of day really refers to where the sun is in the sky, more or less. And there's more to it than that, and we'll talk about it more, but different places are viewing the sun or they are not viewing the sun, which means that it is nighttime for them. So there's a little bit about time zones, the prime meridian and standard time. Okay. Oh, by the way, you'll also notice that these are kind of not straight. Part of this is about political decisions, just so you know. Okay, so let's talk about latitude. These are the lines of parallel. We start at the equator, and then we go north to 90 degrees, and we go south to 90 degrees. Okay, the lines of longitude go from 0 to 180, right, east and west. Okay, we already talked about great circles and small circles, so we'll move on from there. All right, so let's just look at the latitudinal geographic zones, right? As we are viewing the area around the equator, we're talking about the tropical region or equatorial region. Then we move into a subtropical zone on either side. Here we've got this dotted line is going to represent those trade wind areas. We'll talk about those more later on. Then we move into the mid-latitudes where we live. Then we move into the subarctic, which is like the permafrost tundra area. And then we move on up into the Arctic and the Antarctic. Now, the reason I've put this in here is this is going to be a very important conversation later about the connection between the Earth's surface and atmospheric movement. So we're going to come back to that later on. Okay, so let's talk about scale. This basically says how much detail you can see on a map. If you have a bigger scale, right, that's going to mean something different than a smaller scale in terms of the amount of detail. Large scale maps show a smaller area, but they show a lot more detail. So think large amounts of detail. Small scale maps will show a lot of area, but very little detail. So small amounts of detail. Okay. And so when you start looking at this, we're gonna look at this more. We're gonna do some exercises with scale and how it works. So I'm not gonna explain it here. I'm gonna actually explain it in class. But, right, you are basically looking at representative size. So if you're looking at a map that is 8.5 by 11 and it's the whole world, it's clearly a small scale map. If it's the same size, 8.5 by 11, which is a sheet of notebook paper, and it's just the city of Dallas, then it's a much larger scale map, okay? And again, we'll come back to this later in class. Okay, so let's talk about distribution. Most of the time when we look at a map, we're going to be looking at the distribution of things, the situations of things, in addition to just their site. And so there are three main features that go with distribution of stuff, right? And that is the density. Where is it concentrated? Like how much you have in a certain amount of area. Then we're looking at the concentration. Okay, and then we're looking at the actual pattern of distribution. And to give you an example, right, here we have a map of the Great Squirrel War of England. So we introduced, well, we didn't, the English introduced gray squirrels into England. Their native squirrel is the red squirrel. It's adorable, it's slow, it's fuzzy, it's squirrel nutkin, for those of you who know who that is. And then for the gray squirrel, we're kind of like the Ferrari of squirrels. They're fast, they're aggressive, they eat everything, and so they take over because red squirrels are like the Model T, they take over in a short amount of time. So there's this big like squirrel to-do going on in the environmental science world. But that's not important. What's important is that you see these maps, right? So what you're showing what you're shown here is the distribution. So we're looking at three things. We're looking at the density. This map doesn't actually tell you the density. It does, however, tell you the concentration. So density would be specifically the number of squirrels per unit area. This map doesn't actually show that. It does, however, say that red squirrels are more concentrated in this area right here. And by 2010, it's only this area. And then you get the concentration of gray squirrels here. Here you have both of them. So if we go back to that slide before and we're looking at density, concentration, and pattern, you don't always get to see all of those things, but the concentration will in some ways reflect the density. I mean, clearly the concentration of red squirrels here is greater than the concentration of gray squirrels. That means there are way more of them. Okay, so there's a relationship there, but they are different things, and I want you to know that. Okay, here's your next question. The linking of places by common traits or characteristics is defined as... Well, we've talked about place, and we've talked about location. Okay, what we want to talk about right now are regions. When we can start linking locations, places, together, right, we can start developing regions. And there are different kinds of regions. So what type of region would describe the distribution of the Dallas Morning News? So only three of these are actual regions: functional, formal, and vernacular. Okay, and in the case of the circulation of a newspaper, you're actually talking about a functional region. So the answer to that is a functional region. So formal region is going to be like your political boundaries, okay? So like a state or a country. This is sometimes called a uniform region, but formal is more common. Functional or nodal regions are going to be connected. They're going to have some sort of center that is kind of the heart. In the case of circulation, it would be the place from which the newspapers are distributed. You could also be looking at, say, cable distribution or cell phone tower coverage, right? Any of those. It doesn't have to be technology oriented. We just happen to be talking about those because those are good examples for you to think about. But that's a functional region. You also have cultural regions, and the real name for a cultural region is a vernacular region. The South is a really good example of those, and we'll talk about those a lot as we start talking about culture. Okay. Let's talk a little bit about modern geography, or what I like to say, how technology has changed our understanding of the world, right? So first of all, when we start talking about this understanding the location of something, and we're talking about these mathematical locations, nowadays we use GPS, or the Global Positioning System. And so most things are marked now by satellites, and you can orient yourself, GPS, right, by having 3 satellites all communicating with whatever device you are using for GPS, and you will be using your phone to figure out your own GPS coordinates, right, which I think is kind of fun. So where are we right now? So GPS is the #1 like technological advancement that has allowed our mapping to become super, super sophisticated. Okay, and that is a very cool thing. The other thing, right, is just satellites in general, actually, and we'll talk about that more in just a second. Maps have really progressed from the days when we were just looking at, like, where is stuff, right, and we're mapping the known world. We've really started to use maps as scientific tools, and we talked a little bit about this on the first day. But basically, you can take your data and you can show all of these different things. And we've been able to do that on a small scale for a really long time. Airplanes made a huge difference to that, right? To being having more sophisticated, more powerful maps. But really, it's about satellites. Modern technology has allowed us to see through a lens that we have been unable to throughout our history. And so maps are really about spatial analysis. Okay, so when you're looking at a map, this is what we call an integrative action. You are looking at lots of things. The information is being absorbed as a whole. You are able to analyze all of these pieces of data at the same time to come up with a pretty quick, very sophisticated idea about what's going on. And so spatial information is going to be shown differently than like a graph, and it's actually processed differently by your brain, which I think is cool too, just as an aside. So when you start looking at, this is a map, this is the same data that you're seeing here. Which one of these makes sense to you immediately? Well, this one, right? Here's the coastline. Here's some mountains. Very exciting. Here's like, looks like a little farming, city kind of area. Maybe, actually, that's probably more city. Road right here, right? That's easy stuff. You're not seeing that over here. But this over here says the same thing that this does. This is why we use maps. Now, remote sensing is key. Obviously, that map that you just saw was taken, that photo was taken by a satellite. Right? So what we're doing is we're looking at 2 things. One, we can passively sense what's going on, and that's just, we're doing photography, infrared, things like that, and so we're really just getting the energy that's reflected off the surface. So like when somebody takes a photograph of you, they're looking at the light reflected off of your face, right? Or when you take a selfie or whatever you're doing. We can also do some different kind of stuff, right? We can bounce energy off the surface and measure the reflection. And this is active remote sensing. This is going to be your radar, LiDAR. Okay, this is how we do like this kind of stuff, right? So here's just a regular photograph of this beautiful volcano. Okay, this is passive, right? We're getting the light reflected off of it. You can see this plume is obscuring your ability to see this part of the face of the volcano. But then when we actually use radar, where we are sending down, bouncing off the surface, we get a whole different picture. And this kind of technology allows us not only to see the surface, but we can actually start mapping underneath the surface too, depending on what kind of signal we send down. And we'll talk about that more later on as well. Okay, but this is kind of the passive it's not kind of, this is passive and this is active remote sensing. And you can see both of them are valuable. They give you two different kinds of information. Oops, sorry about that. They give you two different kinds of information. Okay, so let's talk about GIS, which is different than GPS. GPS is Global Positioning System. It's all about mathematical locations. Okay, Geographic Information Systems. This is the kind of it's the handling, processing, and analyzing of geographic data. It's done with computers, right? And so what you're doing is you're using computers to make maps and overlay data, because maps can actually contain multiple data layers. So if you think back on the first day, we saw a map that was a political map and also had elevation, and then also showed where water was. Though that's actually physical features and cultural features, because it was a political and a physical map, right, together. And so this is what we're talking about with these layers. So we can create this kind of composite system. That is a GIS, right? It's the way in which we create these multi-layer maps. So here is, a lot of times we'll start off with that topographic base, then we start putting on other features until we get a complete composite map. Right? So here's an example. Here's land cover. You can actually see there's some county lines, there's some rivers, other features, but then you also have probably what's vegetation or land cover here. Same thing in this probability for the spread of West Nile. What you're really looking at is mosquito distributions, right? And the ability for mosquitoes to spread, okay? And that's been mapped here. This is a composite of lots and lots of different data points. It's very cool stuff. Okay, so what is the difference between GPS and GIS? I just want this in our head. GIS uses GPS to determine location. GPS uses GIS data. GPS is the layering of data, whereas GIS is the collection of data. GIS is the layering of data, whereas GPS is the collection of data. GPS correlates with GIS, but GIS does not correlate with GPS. That is a lot of G's and S's, let me just tell you. Okay, so now that you've had a chance to think about it, some of these are going to be really tempting to put, right? So essentially what we're saying here is that GIS is very complex. It's this layering of data, it's this mashing of information together. GPS is simply used to determine location of things. So GIS will use GPS to determine location. Okay, why? Why would you do that? Because we can do better stuff, right? We can understand better, but it's really got this great application in the real world. You can make better decisions about locations. Where should you put new construction? Where should evacuation routes go? What if you're trying to connect something, right? Greater efficiency for reducing costs. How do you plan your shipping routes, right? Maintenance schedules. And that can be just running errands, right? You can look at this and figure out how do I want to organize my day so I can run errands better. Well, in order to do that, you need to understand spatially where all those things are, right? Better record keeping, and then making predictions about the future. That's a really important thing, and that's where we're going to really spend a lot of time in terms of like the science conversations that we're having. Okay. Now, the other thing is, I want to talk a little bit about spatial interaction in terms of distance decay. Distance decay is this idea that you will interact with things that are closer to you, and that will decrease the farther that thing is, right? And so there's this fun quote, all things are related, but near things are more related than far things. And GIS has actually kind of helped us minimize some of that distance decay, and we will talk about that later on when we start talking about interactions among settlements and places and stuff. But this is like an airline map, and you can see that just being able to understand how to move planes has decreased distance decay because you can get places faster than you could before. So there's an example, right? And that's that minimizing the friction of distance by understanding these connections. So distance decay, farther things are less accessible, right? And that is called the friction of distance. And the more accessible you can make something that is farther, then the more accessible it is, right? And that is called space-time compression. And when people talk about it's a smaller world than it's ever been before, that is because we've been able to decrease the friction of distance due to technology, which is something we'll talk about later on when we talk about globalization. All right, that is it. Thanks for listening. I will see you next time, and please make sure you ask questions that you have in class. Okay,